Hey, it's Molly from Springboard, and I'm here with Shubhi, a machine learning engineer at SurveyMonkey. Shubhi, thanks so much for being here.
Thanks so much for having me, Molly.
Let's start off. Can you introduce yourself and give us a little bit of your background?
Sure. So I grew up in the Bay Area and I went to undergrad at Caltech down in Pasadena. Over there, I studied business economics and computer science, specializing in machine learning systems. And I've been in industry about 2 years and at SurveyMonkey about 5 months so far.
So, specifically talking about machine learning, what does a machine learning engineer actually do? And how does that differ from being a data scientist or a software engineer?
A data scientist today would primarily be responsible for translating this business problem of, for example, we want to figure out what product we should sell next to our customers if they've already bought a product from us, and translating that business problem into more of a technical model, and being able to then output a model that can take in certain set of attributes about a customer and then spit out some sort of result. An ML engineer would probably then take that model that this data scientist developed and integrate it in with the rest of the company's platform. And that could involve building maybe say an API around this model so that it can be served and consumed, and then being able to maintain the integrity and quality of this model so that it continues to serve really accurate predictions. Software engineers tend to have, two main areas that they focus on. Generally, there's a front-end engineering aspect and a back-end engineering aspect. The front-end engineering is your UI, your UX, what your end users really end up seeing. And then the back-end engineering is developing systems in which data is flowing. There's a lot of logic and business logic that really exists there. And an ML engineer ends up utilizing a lot of what the software engineer, back-end engineer would end up doing day to day, and using their knowledge of data science and ML in order to integrate ML models into engineering systems.
Awesome. And so, how did you get started in machine learning?
There's actually two interesting-ish small stories related to that. So one thing is when I first got to Caltech, my freshman year roommate had been doing machine learning for like several years before that, and I had never heard of it before. And when I asked him what machine learning was, he kind of explained it in the way of you can use data from the past to decipher patterns in the data and make predictions about the future. And that like totally blew my mind, that you could use data from the past to make predictions about the future in literally any space whatsoever. And today, the reason that really drives me in machine learning to kind of pursue it even more, I would say, is it's kind of amazing what you can do with data insights at scale, and ML, machine learning, really allows you to do that.
So, what's a typical day to day, as a machine learning engineer, and what kind of teams do you normally work with?
Sure. So day to day, I might do kind of projects or tasks that are kind of in two kind of different buckets. One might be, more developing infrastructure or platform to automate ML within our organization, and whether that could be making sure that our models are retrained automatically whenever their performance tends to degrade, or whether that means automating the way that a data scientist may want to develop a model in the future. And then the second thing is, as an ML engineer, I'm also responsible for a couple of different models or model services, especially when they're placed into production. So that could be kind of making sure that their quality isn't degrading, that they're still performing as expected, and being able to take the actions necessary if anything were to go wrong. As part of that, I guess the third thing actually might be to where we're working to put other models into production. And as part of that, I'm working with the data science team, the data engineering team, product managers, and also other software engineering teams in order to really make that happen, where the data scientists and data engineers during model development and making sure that this model will still work in production in a practical and feasible manner. And then with the PMs and other software engineering teams who are really responsible for then consuming the model once it's out there in production.
Definitely, that makes a lot of sense. So for those of us maybe who don't know the world of machine learning, what would surprise us about your day-to-day or your job in general?
I think a lot of people have asked me like, oh, so do you end up just typing code on a computer all day long? And I guess this applies to most software engineers too. But I think also because we interface a lot with the business problem at the end of the day, and so we really have to understand the business problem, and a lot of that is collaboration, communication, working with different teams. It's really a cross collaborational effort, and after we've really understood this problem and really translating it into more technical architecture, we still need to, be on the same page about the technical problems there, and then really do we translate that into code.
Definitely, that makes a lot of sense. What would you say is your biggest challenge in being a machine learning engineer?
Having access to clean, reproducible data. At the end of the day, whenever we're developing these ML systems, you need clean data, and you could have the most organized data sets or data pipelines or whatever, but we end up finding again and again that, hey, there's still some improvement here, especially when we get into the realm of trying to automate a lot of our processes, where we don't have access to these certain set of attributes within our data, or we realize that we were able to get this data this one time, but because this data has been, the data ownership has changed, it's no longer available in that way. And because this is a process that's constantly in flux, it's almost impossible to always have that available. But I know that there are a lot of steps that our organization is taking, plus a lot of tools that are coming out that make this process much easier.
Very cool. So speaking more to your journey once you've become, a machine learning engineer, what's a really cool problem that you've solved, and how did you use machine learning to solve it?
So I used to work in the credit union space. I consulted back there, and really interesting thing about credit unions is that they are a few years behind banks in utilizing machine learning within their organization, within their industry, really. And what I was doing for them was to try to demonstrate that ML has value within their organization. And our goal really was to see, can we derive a really simple use case that can be implemented very quickly to show to our stakeholders that, hey, this is very valuable for your organization, valuable for your members. And sometimes you need a little bit more than just ML for to have these projects really come to life and for work to actually happen. And what we ended up doing for that specific project was developing a churn prediction model and putting it into production such that when people came and visited their credit union to, maybe extract money or make a deposit, the bank tellers or the credit union tellers would know how likely this member was to churn or no longer be a member of this credit union, which is really valuable information, and the business got some immediate business value out of this project, and we're able to move forward to even have even more ML projects in their pipeline.
Yeah, that sounds like a really cool and useful project as well.
Yeah.
Kind of piggybacking off of that project, what are some tools and technologies that you use in your day-to-day?
Honestly, as a machine learning engineer, you almost have to be an expert in knowing what tools are out there. In my day-to-day at SurveyMonkey, I am using mostly Python as my main development language, but a little bit of Scala here and there. But in terms of frameworks and technologies, it's really across the board. So I end up using pretty much a lot of the full AWS stack of S3, EMR, Kinesis, Lambda, so on and so forth, but also containerizing tools like Docker, Kubernetes, Ansible, and then on the ML specific side, things like scikit-learn, TensorFlow, PySpark, and so on. Really, there's really a lot of different domains that exist within the tools, and you have to know not just one tool that can get the job done, but almost 3 or 4, because sometimes you might find yourself needing a specific, like, speed versus, the ease of development versus having multiple people be able to collaborate. And when you're making those decisions, you really need to know what's out there.
So let's say someone's just getting started in machine learning. What different types of machine learning jobs are out there right now?
So machine learning engineering as a field is actually in a pretty interesting spot right now because a lot of corporations or businesses have found that, all right, this ML thing is really working for us. So we've got 3 or 4 models out there. If they're working for us, but now we want to scale. We don't want just 3 or 4 models. We want like 25 or 50 or 100 models. And that's where machine learning engineering as a field is really growing to handle that kind of scale. As a result of that, I've found that there are probably 3 groups of machine learning engineers. One is, your ML engineer that works at a startup. They end up doing everything, from integrating your ML model into any consuming service to actually doing the model development, data cleaning, building out a data pipeline. And then, at your more mid-level companies, their ML engineers are really responsible for working with software engineers and the data scientists in order to productionize or deploy a model, which in itself is a really huge task or project. But they may not be as responsible for the actual algorithmic model development. Um, and then there's the third set of ML engineers that I think work at much larger companies, your Googles, your Facebooks, and really I might even call them like ML infrastructure engineers, where they're building the infrastructure or platform to automate ML or to make ML much easier to do within the organization.
Thank you for explaining that. We really appreciate it. So let's kind of go through the interview process. I know a lot of our students are from the Bay Area or West Coast in general, and would love to know any tips or tricks you might have during that interview process.
To be honest with you, interviewing in the Bay Area is very hard. I don't think it really matters. You could be, the best of the best, but it's very difficult to sometimes even get that interview. I would recommend, at least on your resume, listing a lot of different projects that you might tend to do, especially ones that you aren't really commonly performed. I think a lot of people have tackled, say, the Netflix challenge as a project within their engineering courses or even as part of their MOOCs. And a lot of people have tackled things like the Titanic project, and these are very commonly known projects. I would kind of recommend students to try out something in a field that they're maybe really interested in. For example, I'm really interested in sports, and so I've done a lot of sports analytics projects where I'm really working on scraping data from the troves of data warehouses that are publicly available and trying to make some interesting projects out of that. And that's what really makes you stand out, I say, on a resume. Once you maybe get that first interview, I think it's of utmost importance that you know the ins and outs of models for sure. Knowing really the math behind them, why you would apply certain algorithms over some other set, how they work, and realizing that, again, ML isn't really just the modeling part, but there's a greater aspect to it, and understanding how they all really fit together is, really key.
So outside of being extremely passionate about one specific concept and actually having that background in the modeling, what do you think sets apart great candidates from just good candidates?
That when you're really looking at, your good candidates and say your great candidates, when, I'm looking to hire some more ML engineers for our team, is their thought process and their approach to ML. A lot of people really have, the technical stuff down, and that's amazing, but really having a vision of recognizing where is ML within our organization today and the industry today, and where can it really go in the future, and how do I really work to develop systems that allow us to take that step forward for what may come in the future. For example, these days, it's becoming increasingly common or needed to have central feature repositories within your ML systems. And although, say, an organization may not have one today, how can we develop our ML systems such that we can incorporate them later, and really developing and thinking for the future, because this is a rapidly changing field that new technologies and new ideas are always flowing through.
So let's say we're putting yourself in the hiring manager position again. What are some questions that you might ask those who are kind of applying to become a machine learner at your company?
I'm always interested in what people view as important within ML. Really like, does the ML engineer that I'm looking to, have join my team, do they really understand the trade-offs between really high accuracy and really low latency in my models, and within the ML systems overall, and understanding why is one thing more important than the other. And I might ask questions along, like, specific to situations where, let's say, like, I'm going to create a model that detects cancer. What's important to have in that model? And I think I really love hearing from ML engineers themselves, and having be more of a conversation about more broad topics, and then be able to drill down to the specific technical details from there.
Yeah, that makes a lot of sense, definitely. And I know a lot of our students are really passionate about that interview process. So if you were to have someone come in for the interview, what would you want them to bring? A portfolio, anything specific?
I think something that would, blow me away probably is if they have a project or something that they can really point to and show me end to end how this works, why they chose to do or like implement this project in a certain way, the trade-offs really that exist there, what the impact of this project really is. Not in terms of like, hey, I just got 93% accuracy on this, machine learning model, but what was the value that came out of that? Did you help, a team of people detect that there's deforestation going on where they couldn't be able to do that in an automated fashion, or things kind of like that, where that really close the loop on why we're really doing ML, right? We're trying to translate a business problem or a problem into something technical, solving it, and then closing the loop and seeing, okay, what was the impact of solving this technical problem?
So for those of us who do not have a degree in computer science, and if you're an aspiring machine learning engineer, how would you get into that field, or how would you break in?
Honestly, I think in today's world, the need for a CS degree to enter into the field of machine learning or just engineering in general is really going down. That barrier is going down. And there are a plethora of resources out there, especially like MOOCs or just blog posts and everything. And I find myself to this day still, using these MOOCs, blogs, and newsletters all the time in order to increase my knowledge. I think when approaching the idea of kind of entering into a new field, I always like to kind of bucket things and say, like, all right, there are two types of resources that I think exist out there. One is your technical knowledge, your models, your algorithms, your engineering stuff. And then a different type of resource are like the blogs or the essays or the papers that really help think about your approach to the field or approach to solving a problem. And I often think that you have to separate your resources into either bucket and almost apply them 50-50, where I want to dedicate 50% of my time to this technical knowledge that I will look to gain, and I also want to maybe also apply about 50% of my time to this more high-level knowledge of my approach to solving problems or my approach to the field in general, because I often find that there's an imbalance that kind of persists when we try to enter a field without, say, maybe a formal education, and it's really helpful to have both when you're, kind of joining the workforce at the end of the day.
Thanks so much for sharing that. Well, Shubhi, it's been so nice to chat with you and get to know a little bit more about machine learning engineers and more about your job. So thank you so much for taking the time to talk with us today.
Thank you so much for having me, Molly. It's been a pleasure.